Thank you, Sander, and good morning, everybody. So far, you've heard about all the requirements of an agentic enterprise. Now let's talk about how the Agentic Lakehouse meets those requirements to power your enterprise. So AI isn't our experimental intern anymore. It's ready to be a real teammate. But the problem here is that as AI matures, we ask it to do more, analyze more data, answer more complex questions. But we don't give it nearly as much support as we would a human colleague. A human analyst can walk down the hall and ask for clarification on a business term. They can call a DBA when a query is slow. An AI agent can't do any of that. They either have the context and the data they need, or they make up results super slowly. So we're designing differently, because agents are becoming first-class operators with enterprise data. If we want AI to really be a teammate, we need conditions that are tailored to their strengths and limits. That includes access to all your data, governed end-to-end. That includes semantic context, so the system understands business meaning the way people do. And of course, autonomous performance, so answers arrive instantly without any manual tuning. And that's what we've been building at Dremio. Today, I'll show you how, through an AI agent that lets users converse with their data in natural language. All of that is powered by unified data access to keep everything open and governed. Enriched by a semantic layer that gives the agent the business language and gives it context. And autonomous management that delivers all the speed on autopilot. Together, these eliminate the old bottlenecks and create the right environment for AI and for you. So let's double-click into unified data access. In a modern data enterprise, data is everywhere, across catalogs, warehouses, object stores, and in all different formats. Without a unified view, data and metadata is fragmented and siloed. You've got one system looking at tables about customers. You've got the other system looking at sales data. Analysts are wasting their time searching and recreating what already exists. And without a global view, enforcing security and compliance is nearly impossible. You can't know who has access to what data when all your rules are scattered across systems. So that means governance is a nightmare. And this is especially problematic in the agentic world, where AI depends on complete machine discoverable context and a single consistent policy surface. So to handle those challenges, Dremio offers unified data access. This allows you to have a single view of your data, regardless of where it is. It allows you to blend structured and unstructured data, and of course, it allows you to easily and clearly govern your data and implement your access control policies once. So let's go ahead and double-click on all of these capabilities. Dremio's open catalog is machine-readable for agents and governance-ready. It's interoperable because it's built on Apache Iceberg through Apache Polaris, which Snowflake and Dremio co-created. You register your data one time, and you can use Dremio's query engine or any Iceberg-compatible engine such as Spark, Trino, or Flink. So the benefits of the open catalog are twofold. One, you avoid vendor lock-in. And two, your AI tools have governed access to all of your data. Okay. But what truly unifies data for AI isn't just the catalog. It's Dremio's ability to federate queries across catalogs, metastores, databases, all in real time. If you're already using a metastore, such as Unity or Glue, or other object stores or databases, you can query and combine data across all of those with Dremio's query engine and zero ETL. You can also process structured and unstructured data through one engine and have consistent performance and policies. So there's no copying, no pipelines, and no silos. You're cataloging, federating, and processing your data through a single platform. And of course, we know it, not all valuable data is in tabular format. Enterprise data includes unstructured data, which is often invisible to analytics. So think of your images, your logs, or your PDFs that are in object storage. Many of our customers have unstructured data in the form of call center logs or deal memos. And so before AI, they had teams to process that data manually. Now with AI, we all know it's not magic. The more structure and guidance that you can give the agent, the better off we are. And so for that reason, Dremio's introduced AI functions natively into the platform to be able to process that unstructured data. We've got AI Generate, which extracts structured fields and derives signals from unstructured logs and notes. AI Complete helps with completion for text prompts. And Classify helps categorize input text based on labels. Today, I'm going to show you how we can use AI Generate to go from unstructured to first-class governed data, and we'll use that data later on today in the session to produce outcomes. So let's go and see this. All right, so for the demos today, we're going to be a company called Stratus Cloud. They're a cloud-based technical solutions provider. We made the company up. They want to reward their highest support engineers, or their highest performing support engineers, and establish best practices for their teams based on the support engineers that are successful. They're going to do this by analyzing the performance of the support engineer based on the sentiment of the customers that call into the call center. Normally, this analysis would take weeks, maybe months, but I'll show you how we're going to get this down to a couple of minutes. So, we'll start with getting the data that is going to help us address this problem. Every time a customer calls into the call center, a call log PDF is generated and put in an S3 bucket. Each log contains customer details, the support agent details, as well as free text notes from the engineer about the issue. Those call logs are critical for feedback and understanding customer satisfaction, but they're invisible to analytics. They're just PDFs and object storage. So let's change that using AI Generate and make the data accessible to both people and to agents. All right, so we'll start with the S3 bucket that contains the PDFs for the call logs. If we open one of these, we'll see that there's a nice mix of structured fields as well as unstructured notes, again, from the support engineer. And now we'll go ahead and go to the SQL runner and use our AI Generate function to pass the call logs to the model along with a prompt, the location of the data, and the schema of the table that we want to put it in. The prompt is telling the model to extract some basic fields as well as derive new ones, such as sentiment. And these rows, when we run this function, the rows that are being extracted will be inserted directly into a governed Iceberg table. Now that that's done, let's verify that the data has actually landed in that table. I'll run this query real quick. And you can see the extracted fields as well as some of the generated ones have shown up. So just by a single function call, we were able to take PDFs from unstructured to structured, queryable, and governed. All it took was a single function call. We didn't write pipelines. We didn't have to do any manual processing. We just took raw files and turned them into first-class data that is available for both agents and people to use. So rounding out unified data access, governance is a must-have more than it has been ever before. Governance creates guardrails for the agent to operate in, which then develops the credibility so that you can trust the responses that are coming back from the agent. Regardless of where your data lives, whether it's structured or unstructured, unified data access gives you the power to streamline governance and have a single policy surface area. And with Dremio's unified data capabilities, you're able to set access control policies, and that goes all the way from role-based access down to the most granular level of row and column-based policies. And you do that across all your data. All of those are enforced for every single query, whether it's coming from a person or an agent. So what does this mean? This means that when an analyst comes to Dremio's AI agent or any other agent, and they ask a question, the agent only has access to what you've authorized that user to see, regardless of where that data is living. And beyond that, through lineage, monitoring, and audits, the agent can track where the data is coming from, how it's been transformed, and how it's being used, which then helps the agent develop trust in that data, pick the right data to use, just like people reason through that. So to summarize, Dremio's unified data access capabilities allow you to maintain an open and governed data catalog. You can pull together structured and unstructured data and federate queries across multiple sources. Again, governance is the key piece here. That allows you to ensure security and build trust in the responses that are coming back from that agent. And now, as we build on unified data access, determining the meaning and the relationships between the data is often the hardest part. If you pick the wrong definition of a field, or you pick the wrong time period, your conclusions are going sideways within seconds. A human can ask a colleague, an AI agent can't. It either has the context or it's going to make it up. We all know this, we've seen this. And so that's where Dremio's AI semantic layer comes in. It's a built-in business dictionary that captures entities, relationships, and definitions, all with the data. So if fiscal Q2 means April through June for you, that definition travels with your data and surfaces automatically in discovery and analytics. Why AI semantic layer? That's because this is where AI agents come to get all the context they need to deliver an informed and actionable insight. And we'll double click on two key aspects of the semantic layer that make this entire process possible: enriched semantics and semantic search. So in Dremio, each table, view, and folder stores the semantics that are required for the agent to reason, right? Which data to use, how to interpret it. And so what enriched semantics allow you to do is generate tags to classify your data that will inform the agent how to use the data. For example, if you've got confirmed leads as a tag on a view, this might tell the agent that it's the right data to look at if we're trying to determine who to send or who to target for a particular campaign. And of course, with enriched semantics, you can also generate and enhance documentation to define business terms and provide usage notes. So again, the agent can understand, how do I use this particular data? And then when the data includes these semantics, discovery through semantic search identifies that data and understands whether it's relevant to answering your question, whether your columns are named correctly or not. Semantic search isn't just a feature in the Dremio console. It's the same capability that provides the discovery tool for the Dremio AI agent you saw earlier. This way, when you ask the agent, who are my most successful customer support engineers, the agent leverages semantic search, which is powered by the semantics on the data to determine which data will answer the question accurately, all while ensuring that the access policies that you've set have been applied. So to recap, AI-enriched semantics on data provide the context the agent needs to successfully and accurately reason through the question that it's being asked. And semantic search is the tool that pulls that context and the semantics to present the relevant data correctly. Due to these capabilities, the semantic layer the agent doesn't need to guess or improvise, and the answers align with your business language. And the need to invent interpretation of data drops significantly. So now I'll show you how easy it is to add semantics to your data. We're going to go back to the same scenario we had before. We're trying to understand who our top performing support engineers are, and we're doing that by analyzing the sentiment of the customers that call in. So going back to the call logs table that we generated from PDFs, we'll add semantics so that everyone and every agent has the same meaning and they have the same context. So when someone says negative sentiment or fiscal Q2, everybody knows exactly what that means, and there's no guessing involved. So here we go. We'll open up the call logs table that we created before, and it's got some basic metadata, but without business definitions, it's all ambiguous. So we're gonna go ahead and generate those business definitions, and then we'll make some updates here to include a couple that we know about, as well as some common questions that might be asked to inform usage of this. So what happens with these definitions is, like I said, they travel with your data, and they get considered in meanings, classifications, and all of that. And so then here, we're gonna go ahead and generate tags for this data as well. Now that we've done that, that's all it took. We just generated both documentation, example queries, and classification tags. We're gonna go ahead and do that for the other two related tables as well. And once you've done that, all three related tables have shared context, shared relationships, and now that agent can use that information to go ahead and reason about the question that we're gonna be asking in a second here. So we've got accessible data now. We've got meaning and context on top of that using the semantic layer. The next step is to see how's the AI agent gonna use all of this to produce insights. Today I'm excited to show you how quickly you can go from question to insight to action with Dremio's AI agent, which is powered by the unified data access and the semantic layer that we've already talked about. Instead of writing SQL or clicking through dashboards, all you have to do is ask in natural language, and the assistant does the heavy lifting. The interface bridges technical and business users because everyone's able to describe their need in business terms and start to explore their data immediately. It's like having a data expert at your side. That expert's our Dremio AI agent. And because the agent is reaching out to your catalog and the semantic layer, it discovers the right data sets, applies the right definitions, understands lineage, and respects the access policies that you have set, all by default. Answers reflect your business language. Again, doesn't matter how you've named the object or the columns. And you're choosing the model, whether that be from OpenAI or Anthropic or Gemini. Beyond that, if you want to build a custom application, you can do that using Dremio's MCP server, which leverages the exact same tools that Dremio's AI agent does for consistency. So now let's go over to that demo. Again, at this point, we've already got our call logs structured from what they were before, which was PDFs. We've got semantics attached. So for this demo, we'll step into the shoes of an analyst and go ahead and start that analysis of who our top performers are and what best practices we can implement depending on their methods. And we're gonna do that by looking at customer sentiment. All right, so we'll go ahead and ask the Dremio AI agent in the Dremio console to give us a little bit of information on the data that we have available for call logs. It's gonna reason through and discover the table that we've created, as well as some of the ones that were created earlier. And you see that within a few seconds, we've got an overview of the data that we have available. So now let's go ahead and ask it a question about average support engineer performance. And you'll see that reasoning happening again. This time, we are writing, validating, and running queries using Dremio's query engine. There are several SQL statements that get generated to go ahead and answer this question, but this happens pretty quickly, and we get a pretty extensive response grouped by teams here on who's performing well and who's not. And so now we'll go ahead and ask kind of double click on that analysis. And again, you'll see SQL statements being generated, validated, and run. We asked for a chart. We asked for some patterns and trends that the agent can find in the data, but it went beyond that. It went ahead and started to talk about actions that we can take based on the patterns that it's seeing. So you've gone from question to insight to actions, all within a couple of minutes. We didn't write any SQL. We didn't really do anything beyond just ask the questions and get the responses. Now, are these responses going to be perfect? No, but this is a great place to start. And we've gone from analysis that would take weeks before to just a few minutes now. So we've seen how the agents use data. Now we'll look at how Dremio delivers speed on autopilot. Performance is usually the last barrier between a great idea and an actual answer that you can act on. Agents aren't going to ask somebody to tune the system or open a ticket. They expect reliable responses at any hour on any data set. And making sure that these AI queries run quickly without manual tuning is critical. Dremio achieves this through autonomous management, which is a set of capabilities in the query engine that keep performance on autopilot based on active metadata that's generated based on your query patterns. So let's dive deeper into each of these capabilities. With Optimize, as data grows, you shouldn't have to worry about maintaining it. Dremio automatically cleans up snapshots and does automatic compaction, so there is no additional intervention required from you to keep maintaining the data for AI readiness. Clustering. With clustering, we've removed the challenges of partitioning by co-locating and ordering data based on clustering keys. This happens by combining small files or breaking up large ones. All in all, you're not having to constantly reevaluate those error-prone partitioning schemes because clustering is dynamic and changes as your data is evolving. And finally, Dremio leverages active metadata based on generated patterns from your queries and autonomously rewrites the queries in real time to leverage those materializations that we call reflections. The system keeps reflections up to date based on the changes to your underlying data and changes to your patterns. So if your query patterns change and you're not interested in sales data anymore, you've moved on to something else, your reflections get updated to do the exact same thing. Again, no manual intervention from you. And together, these capabilities make up autonomous management, which is more than just an optimization. It's a self-tuning system. Queries, whether they're triggered from an agent or from a human, start running faster without any knobs that you're turning or without any tickets that you're filing. In an agentic workflow, autonomous management isn't just a nice to have, it's required. When we were working with Dremio's AI agent, queries were coming back pretty quickly, and that wasn't an accident. We'll come back to the call logs data that we've been looking at throughout this session, and now it's grown from the 100,000 records that it was to 2.4 billion rows. What we're gonna do in this demo is turn off our autonomous management capabilities and ask the same question that we did to the AI agent previously. What we'll see is that without optimizations, clustering, and materializations, query's gonna take some time to come back. Then what we'll do is turn autonomous management back on and allow the system to pick up the patterns. And we'll ask the same question again. And you'll see the performance of the query that's been generated go from 26 seconds to sub-second without me doing anything. So let's go ahead and take a look at this. So we're gonna ask that question we asked towards the tail end of the agent demo. And we're gonna see that it is gonna take a while to come back. Autonomous management capabilities have turned off. We're at billions of records, and there's no optimizations or materializations coming back here. So we might be waiting for a while. Let's cue some music. When data grows, not even a super fast engine can take care of all of that without the data being optimized and materialized and clustered. So we've got the results that came back. Took a minute. Actually took 26 seconds, and we can see that here. So now let's turn our autonomous management capabilities back on and let the system pick up some patterns. You see that it's created a reflection here, and it's going to rewrite queries to use this reflection. We'll go back to our Dremio AI agent and ask the same question we just have been asking for the last couple of times. And with optimization, clustering, and materializations in place, you're going to see that this comes back fairly quickly. See, no Jeopardy music needed. If we go back to the jobs page, you'll see the difference. 26 seconds to 1 second. Autonomous management keeps queries reliably fast, whether they're triggered by an agent or a person, without manual tuning, without any manual maintenance. And this lets agents react in real time. So to wrap this up, we'll go back to the data platform pillars we talked about earlier. With an open catalog, query federation, and unstructured data processing, you're getting a complete picture of your data. AI-enriched semantics and semantic search provide the context agents need. And role-based access, fine-grained access, lineage monitoring, and audits all make governance possible. Of course, as we just saw, optimize, cluster, and materialize, and query rewrites enable automation. So that's how the Agentic Lakehouse meets the requirements of an AI data platform. The unified data access layer provides a complete picture of your data and allows you to create a trusted data foundation with governance. The AI semantic layer provides the business meaning to the agent, so it's speaking the same language as you. And of course, autonomous management allows performance to truly be on autopilot. And this is how we set AI up for success in modern data enterprises. With that, thank you.